Hello and welcome to Software Architecture course. We will continue with design patterns. So in this lecture, we will study the structural design pattern. In this lecture, we will consider a set of design patterns that are important for structure. Now, let's look at another important pattern called the composite pattern. So to understand composite pattern or composite objects, let's first understand what is primitive and what is composite. So let's try to understand from the real world. Basically, primitive objects are atomic objects which cannot be broken up any further, but they've also formed the basic building block using which another object can be created. Example is this, that there are these screws and nuts and bolts. These are basically atomic objects. The composite objects are basically collection of the objects which can contain other objects as well. So composite objects is a collection, and each element in the collection can either be a primitive or can be a composite, is what I'm trying to say. So a composite object might look like this here, which is quite complicated, but it is actually built out of these. This is the main point here. So the composite basically lets a client treat individual objects and compositions objects uniformly, in a sense that for the client, these atomic objects like these screws and nuts and bolts, these primitive objects and this complex object should be treated in a similar uniform manner, meaning that all of them would have the same method. Let us look at a typical GUI application and see how these composite objects can be used. So in this example, the primitive objects are essentially buttons, like different types of buttons, including radio button, checkbox, text fields, and so on. And the composite objects could be frames and panels. If you are using Java, then it could be JFrame or JPanel. Let's look at this picture here. This is actually a composite object. So this is the panel consisting of 3 elements. This is another panel consisting of labels. This is another panel consisting of buttons. So one important part or one important observation here is that these particular buttons here, like start conference, add, remove, these buttons are essentially the primitive objects. However, and obviously these are used to form a composite object, but the composite object, which is this big GUI here, this window not only has primitive objects, but it also has composite objects. So essentially it is built in a recursive manner. There are primitive objects like start conference button, cancel button, then there is a text area, white text area here, plus it has panels. You see, this JPanel is essentially a composite object. It has a panel like this, it has another panel here, it has another panel here, and inside this panel, which is composite object, there are again buttons and labels and text boxes. So this composite object consists of even more fine-grained composite objects and primitive objects here. So this is the example, but let's look at the requirement. Why do we need a composite pattern? So we need composite pattern when there is a requirement that some operations that need to be applied, there are some operations that I need to apply onto both primitive as well as composite objects. Therefore, interface for operations, whether it is primitive or composite type, must be the same. I should be able to use the same interface for both primitive as well as composite types. So when an operation is performed on a primitive type, it is also atomic in nature, but when this operation is applied on a composite type, then it becomes kind of recursive in a sense that the operation that is applied on composite type, that operation in turn applies the similar operation on its components. So in that sense it becomes recursive, and depending on what is the level of nesting, depending on what is the level of division of modules into submodules and sub-submodules, then the level of recursion actually goes that much deep. Let's look at the example of GUI application. I have the interface, which is the GUI shape. GUI shape is an interface, and many objects actually implement these interface. So first of all, the interfaces like button, text area, text box, label, they all implement it. Plus a composite shape also implements this GUI shape, and my GUI app essentially has a collection of GUI shape objects. So the first step is to create an interface for all these common objects, which is GUI shape. Second step is to implement the primitive objects first, like buttons, text areas, and so on. Then define the composite objects. Step 3 is that implement composite objects in more detail, specifically some important functionality. In this example, let's say render. This render method, which are there in all these objects, which are some are composite, some are primitive. So for button, the render is basically an atomic operation. It actually implements how to render a button. But in case of composite shapes, the render method of composite shape will actually call the render method of button, it will call the render method of text area, it will call render method of text box, and so on, if this composite object is constructed out of a button, a text area, or a text box. So how would this composite pattern be used? So here, this my GUI app, which is the client, is going to use this composite pattern in the following manner. Look at this main method, and there are first 4 set of calls which are going to create the primitive objects. So in this example, I'm creating a button, labels, text boxes, different types of buttons I'm creating: shape, remember button, shape add button, start button, cancel button, and so on. Then I'm going to create a composite object. So this composite object, here in this I am actually adding a button. Actually I am adding 2 buttons, add button and rem button or remove button. I am adding a shape, then I am adding another shape called IPT or text box. So I am adding IPT, IPL, these are all objects, rem button, add button, and that's what is my complex component. So I have one more composite object which is called the very complex shape. This very complex shape here, it basically creates a composite shape, and in this very complex shape I am adding this complex component. So note that here this very complex shape basically has a slightly less complex but still composite object, which is complex component, this one. Plus I'm adding additional buttons. So these are the primitive objects, start button and cancel button, and this is a complex object, complex component, which is this one. So this is how I'm first creating simple set of shapes, then I'm creating slightly more complex, then I'm creating even more complex shape, and then I'm saying very complex shape dot render. This render will call render method of all these buttons, and render method of this will call the render method of add button, rem button, and so on. So what are the consequences? The composite pattern defines the class hierarchy or containment hierarchy. Actually, of course it creates a inheritance hierarchy, like primitive objects and composite objects, that creates a inheritance hierarchy. And as I have explained earlier, primitive objects can be used to form more complex objects, but it also contains a containment hierarchy, like a very complex object, very complex shape contains a complex component. A complex component contains a button. Now client basically treat primitive as well as composite objects uniformly throughout in the code, and then it all treats basically all of them as a GUI shape. So that makes the client code really simple. Adding a new component can be really easy, and a client code really does not need to be changed. So I can add different types of buttons, different types of complex shapes, and my client code need not be changed. For example, if I, let us say, create or change a button type, then that will be automatically reflected in my client code.